Hello everybody, this is Mr. Plugs. This is 11D graphing part 1. Okay, let's see here. What do we got? A rational function is a formula that is written as a fraction. So I suppose technically something like x over 3 is a rational function, but we tend not to think of it as that because this could be written 1/3 x and the graph of that is just a line. So a rational function that we think of would have an x in the denominator, which then changes things. Some weird things happen to the graph when there's an x in the denominator. Okay. One of the weird things that happens is you get graphs that look like they're separate pieces. So if you can see this graph, it looks like there's 3 separate pieces. That's one thing that can happen with a rational function. Okay, to split these pieces, we have what are called asymptotes. So a vertical asymptote is an imaginary vertical line that the graph approaches but doesn't cross. Horizontal asymptotes are kind of the same thing. They're imaginary horizontal lines that the graph doesn't cross at the end, but the graph can cross them in the middle. So I'll try to explain that in a second. Okay, so this is a rational function because there's an x in the denominator. So this would be a common rational function. There are imaginary vertical lines that the graph approaches but doesn't cross. There's one here at 1. So a vertical line is x equals 1, or x equals any number is a vertical line. There's one here at, or actually maybe that was 2. 1, 2, 3, 4, 5, 6. That was x equals 2. Okay. That was x equals 2. And there's another one here at -2. So the end of the graph here, it's the end of the graph as the graph gets closer and closer to the asymptote. It doesn't cross it, but it gets closer. Okay. Then there's an imaginary horizontal asymptote. It appears at about 1. So that's an imaginary line that the graph comes close to but doesn't cross. So it looks like there's an imaginary horizontal line at y equals 1. Now when we graph rational functions, I'd like you to put in the asymptotes so it's clear what the graph, the ends of the graph come close to but don't cross. So there's 2 horizontal asymptotes at x equals -2 and x equals 2. There's a vertical asymptote at y equals 1. Now, the domain we talked about a long time ago. The domain is what inputs have outputs. So the domain is the inputs that have outputs. So in the graph above, every input, all real numbers, every input has an output except -2 and 2. So in asymptote, there's no output. So the dotted line reminds us that we can't cross over that. Okay, in the next example, this is also a rational function where there's x's in the denominator. Okay, there's horizontal asymptotes. Oh, shoot. I usually list my vertical asymptotes first, so I goofed them up in the last problem. Maybe I'll start over. No, I won't. I'll just switch it. Okay, I switched my vertical and horizontal, sorry. Horizontal was y equals 1, and vertical is x equals -2 and 2. So sorry about that. I had to just change that to the correct spots. Okay, I usually list my vertical asymptotes first, but this one I didn't. Okay, there is a imaginary horizontal line at 2 So the horizontal asymptote is y equals 2. The vertical asymptote, is there an imaginary vertical line that the graph comes close to but doesn't cross? No. There's no vertical asymptote in this one. And the domain, since there's no vertical asymptote, the domain is all real numbers. So that symbol stands for the real numbers. Basically, we're not worrying about imaginary numbers right now. Okay, so now you can pause the video and try just these 2 practice problems, identifying your horizontal and vertical asymptotes. Horizontal is in the form y equals, and vertical is in the form x equals. So pause the video and try those 2, and then we'll pick up where we left off in just a couple minutes. Okay. Based on the graph to the left, what is the x-intercept? Okay. The x-intercept is -2. What is the y-intercept? That's also -2. The vertical asymptote is at 1. And the horizontal asymptote is also at 1. Okay, make that a tiny bit neater. The equation for the graph above is y equals x plus 2 over x minus 1. How can you find the x-intercepts from the equation? Okay. The x-intercept is a point. The point is -2, 0. Okay. So what you can do is set the numerator equal to 0 and solve. So in our problem, we would have x plus 2 equals 0, x equals -2. Sure enough, it works. The reason it works is at an x-intercept, the y value is 0. So this is the point -2, 0. The y value is 0. So if we set y equal to 0, any fraction with a 0 in the numerator, 0 divided by any number equals 0. So it's just the numerator that needs to be 0. Okay, how can you find a y-intercept from the equation? You can substitute 0. You can substitute 0 for all the x's and reduce. Okay, the reason why this works, in our problem, the y-intercept is the point 0, -2. So in this problem, x equals 0. So if x is 0, you get a y-intercept. Okay, how can you find the vertical asymptotes from the equation? You set the denominator equal to 0 and solve. So in our problem, we would have x minus 1 equals 0, and we would get x equals 1. The reason this works is when the fraction is undefined, When the fraction's undefined, you get an asymptote. And you cannot divide by 0. If you take any number divided by 0, that's undefined. Okay, so now we'll try 2 problems. Okay, we'll try to find the x-intercept algebraically and then check it with the graph. Okay, so what is the x-intercept? Let's see here. The x-intercept should be 2 and -2. So they're the points 2, 0, and -2, 0. So how can you get a fraction equal to 0? It would be the numerator. If the numerator equals 0, the fraction would be 0. So you can add 4 to both sides, and then square root, and you get plus or minus 2. It works. Okay, the y-intercept, it says on the graph, is 4. So the y-intercept, you plug in 0 for all of your x's. So y equals 0 squared minus 4. So it's 0 minus 4 over 0 minus 1. So -4 over -1 is 4. That works. So we're doing okay. And the vertical asymptote is the denominator equals 0. The vertical asymptote is the denominator equals 0. I'll just write it in a different color. Okay, add 1. Square root. Don't forget your plus or minus. And look up above at 1 and -1. You have vertical asymptotes. So that also works. Okay, one more just to make sure you got the hang of it. So the x-intercept was numerator equals 0. Add 4, square root, get plus or minus 2. Look up above. We'll double check. Sure enough, plus or minus 2 works. Y-intercept is 0 for all of your x's. 0 minus 4 over 0 minus 1. -4 over -1 is 4. That works. Oh, looks like the same as the last one. Except here, the denominator is different. There's only one vertical asymptote. Okay, so what you guys are going to try is finding them algebraically, making sure you show work, and then match it to the, so make sure you show work and then match it to the graph. So good luck. If you have any questions, we can discuss it.